Hi and welcome. So in this video I'm going to continue the discussion about using inverse trig functions with our special angles. We're going to do some more examples and get more in depth. Throughout this video, I'm going to be referring back to this picture of the unit circle with the different inverse functions labeled on it. So this will be helpful to have to refer back to because I'm not going to have it on the screen just because it's going to be hard to have it there with everything else I'm also writing. So just know that it makes sense for you to have this as you're working through the problems. So for these examples, I'm going to draw out our reference triangles that work with our special angles, and I'm going to refer to these pretty extensively. So you can use a unit circle too, that's totally fine, and I'll show you how, but I like to work with these reference triangles as well, because this skill is going to help us when we start to use things that aren't on the unit circle. So our special angles work for the unit circle, but there's lots of angles in between, and we need to have some skills to use for those angles too. So we're going to evaluate three inverse trig functions. We're going to do arcsine, or the inverse sine, of negative square root of 3 over 2, arccosine, or the inverse cosine, of negative 1/2, and arctangent, which is inverse tangent, of square root of 3. So the first thing I do when I start these is I look at whether the value is positive or negative, because that will tell me which quadrant I'm looking in. So on the first example there, I'm looking at the arcsine, I have a negative square root of 3 over 2. That negative tells me I'm going to be in quadrant 4. My options are quadrant 1 or quadrant 4, and quadrant 4 is where sine is negative. Then I remember that sine is opposite over hypotenuse. So I want to look up to my triangles and look at where am I having opposite over hypotenuse be square root of 3 over 2. Well, if I start at the angle pi over 3, which is 60 degrees, and I look opposite, I'm getting square root of 3, and then I have a hypotenuse of 2. So this angle pi over 3, which is 60 degrees, is going to be my solution. Specifically though, I need to make it negative since I'm in quadrant 4. So my solution is going to be negative pi over 3. I like to use radians, you can use degrees if you'd like, just a note. I'll show you this on the unit circle too at the end, but hopefully this is making sense for now. Let's try it on another one. So for arccosine, I'm looking at negative 1/2 as my value, and so this negative tells me I'm in quadrant 2. Remember, from my image of the unit circle, my options are quadrant 1 or quadrant 2, but quadrant 2 is where cosine is negative. Then I remember that cosine is adjacent over hypotenuse, and so I'm looking at my triangle to determine where I have adjacent over hypotenuse. We're at pi over 3 again on this same triangle. 1 is adjacent, 2 is the hypotenuse, and so I'm looking at the reference triangle of pi over 3. But I need this to be in quadrant 2. I can't use pi over 3, that'd be in quadrant 1. So I need the corresponding angle in quadrant 2, which is 2 pi over 3. So 2 pi over 3 is my solution. Then for arctangent, I have arctangent of a positive value, square root of 3, and so my options being quadrant 1 or quadrant 4, tangent is positive in quadrant 1, so I'll go with that one. Then I remember that tangent is opposite over adjacent. So looking here, I have to be again at this angle pi over 3. Opposite is square root of 3, adjacent is 1. Square root of 3 over 1 is just square root of 3. And so I'm looking at this triangle for pi over 3, which in quadrant 1 is just pi over 3. So these all actually started at the same angle. All of these examples started at pi over 3 for my reference triangle, but they all had different answers. So arcsine was in quadrant 4 with a negative pi over 3. Arccosine was in quadrant 2 with a 2 pi over 3. And arctangent was in quadrant 1 with a pi over 3. Let's look at the unit circle to make sure we know how to do it there. I think you're going to find this is easier. I just kind of like to show you the other way too. So for inverse sine, we're looking at the sine value, that's the y, and we want to find where is it negative square root of 3 over 2. Well, I can sort of just circle it here. I see this is the angle 5 pi over 3, but we need an angle from negative pi over 2 to pi over 2, so I'm going to write it as negative pi over 3 instead of positive 5 pi over 3. So okay, that's my solution there. As I said, I think you might find that easier. So for cosine, cosine is the x. I'm looking at where is it negative 1/2. My options are quadrant 1 and quadrant 2, but I'm looking at this -1/2 in quadrant 2. This corresponds to the angle 2 pi over 3, so my solution is 2 pi over 3. I can repeat this with tangent. This one's a little bit harder, so I know that tangent is sine over cosine. So I'm looking for a square root of 3 somewhere, and I'm seeing that if I have square root of 3 over 2 as the y and 1/2 as the x, if I simplify, I'm getting square root of 3. So this one's a little trickier, and this is partially why I like to have the triangles. With the tangent, it can be kind of hard to look at the circle, so knowing how to use the triangles is helpful. But this is pi over 3 as our solution there. And there we go, 3 more examples. So it's hard to show you every possible example, there are so many, but we continue to use this process as we build up on this concept. So as we start to use other angles and as we do compositions, you're going to find that we do this same process over and over. So I don't want to do too many things right now, I want to make sure we save time to do those, and hopefully you're going to get a lot of practice repeating this same process. That's it for this video. Thanks so much for watching, and I will talk to you in the next one.